Hey everybody, today I just want to do a quick video on how we can measure current in LabVIEW using DAQmx. So we've kind of talked a little bit about things like temperature and voltage. So now let's talk about how we can measure current. So current, there's a lot of different ways you can measure this. Even with DAQmx, there's multiple different ways we can measure this. So just kind of starting off, I just want to highlight high level the different ways you can accomplish this, and then we're gonna kind of dive in to some other the actual applying of the code and everything to do this. So first, there's always external devices you can use to convert current to voltage. So there are a lot of different like current transformers and stuff that you can use that'll take a voltage and basically output a analog voltage signal, and then you can measure it with any voltage capable device. So you would, instead of measuring current directly, you would be measuring voltage, and you would have a current transformer that is giving you that voltage. So I'm not really going to cover how you can do that in LabVIEW because that's really a matter of instrumentation, and then it's just the same as reading voltage as we've covered in previous videos. Now let's talk about how you can measure current, at least more directly in LabVIEW without using external equipment. So there's kind of two ways you can do this. So I'm going to pull up way one, and this is probably the simplest. So this is a C-series module for measuring current. So this is the NI9227. These work great. 24 bits, 50 kilosamples per second per channel. Really cool. 0 to 5 amps. Pretty cool little sensor. You got 4 channels. So this basically has an internal, and you can see this over here, an internal shunt resistor. So inside of this C-series module, there is a shunt. So we basically just have a plus and minus for each channel. So basically we're going to need to wire this in series with our circuit. And I typically will put these on the ground side. There might be instances where you want to put them on the power side. I've just pretty much always done ground side. So we'll basically connect our circuit in to the plus and our circuit out back to ground on the minus. So you're basically just passing the current through this device. And like I said, inside there is a shunt. And this is basically giving you a voltage drop across a known resistor. But the card itself is then able to convert all of this back up to current for you when you query DAQmx and say, hey, how much current is on channel 1 right now, right? Well, you get a current value, not a voltage value out. So this is a really cool, clean way to do it. I've used these modules. I like them a lot. They're great. And there's other similar C-series modules for different ranges. So this would be like a 0 ARMS to 5 ARMS. There's one specifically for like your 4 to 20 milliamp range, and some that are like negative 20 to 20 milliamp range. So pick the right one for what you're trying to measure. But yeah, there's a lot of different options there. So this is way one, right? So you're using basically the C-series module with an internal shunt to take your current measurements for you. Now, way two would be that you can use a voltage measuring device that's not directly capable of measuring current, but you can add this shunt externally to the circuit. So you can still add your own shunt resistor. You need to determine what value you want to use. So let's say, for example, we're using a 1 ohm resistor. So that's a good value in a lot of use cases because using Ohm's law, V equals IR. If R is 1, then V equals I. So therefore, the voltage you are reading is equal to the current that's passing through the circuit. So that's a really easy way from a math perspective to convert voltage to current. Sometimes though, right, you can't do a 1 ohm resistor, so you might try something else. Regardless, DAQmx has a cool way to handle that for you, and I'll show you that. But yeah, the basic idea would be I can take anything that can measure voltage and basically add a shunt somewhere outside of this, and I'm just measuring the voltage drop across that shunt resistor. And now in DAQmx, and I'll demo this in just a second, I can specify that I have an external shunt and what its value is, and then when I query DAQmx for the latest data, I'm getting the scaled to current data out. So I don't need to read a voltage and then do some math using Ohm's law to convert that, although you can do that as well, right? You can just read voltage and then know, hey, V equals IR, so, V divided by R gives me I, and maybe my R is, 5 ohms, right? Well, divide by 5, boom, that's my current. So that's an option as well, but DAQmx can actually do that for you. So, let's just set up a real simple, using our common pattern we use for everything, right? We're just going to use a create channel. We're going to start the task. And we're going to do a DAQmx read. Sorry, the wires were not coming out all that straight, but our stop at the end, and let's add our clear. Okay, so we have this simple pattern that we're using for essentially, all DAQmx stuff, right? It doesn't really matter what we're doing. When we're reading analog input data, we're always more or less following this structure. And we can put a while loop around here, add a stop button, and I'm going to change this to single channel, multiple samples. Okay, so let's just define some of these last settings. So let's say our sample rate, we want to be 1,000, sure. And let's set our sample mode to continuous, and we're going to read, let's just do 250 samples at a time. And I'm just going to drop a waveform chart there so we can see the data coming out. Cool. So we've got everything configured now. We just need to go back to this initial create channel function. So we need to instead go back to analog input, but instead of selecting voltage, now we're going to select current. There's also an option for current RMS if you want the RMS value. Just for this simple example, I'm going to use current. Functionally, they are pretty much the same. I'm going to create a channel just like any other type of task. I'm going to select this, which is, I have a simulated NI9227 right here. So this will be method 1, this guy, where we're using an internal shunt to read current. So there's a few options here. We have units. So we can specify units. Our options are just amps though. Custom scale. We also have this shunt resistor location option. So we can either do default, which is just going to be the default for the module. We can also specify internal or external. So this is the NI9227, which uses the internal. We also have min and max value we can specify. So let's set those. Let's say, let's say 2 amps max and 0 min, something like that, right? And we do have an input terminal configuration, which again we have the same options we do when we're measuring voltage. I'm just going to leave it as default. That will matter more so as we are using method 2. So for now, it doesn't matter. When we get to method 2, that will be a critical thing to set though. And there is, lastly, this option for an external shunt resistor value where I can input the actual shunt resistor value. Now, because we're using internal, I'm not going to set this, but when we come back to method 2, we will come back and revisit that. So yeah, now I'm basically set up to read current. So I'm just defining analog input current instead of voltage. I'm specifying whether I'm using an internal or external shunt, but then everything else is exactly the same as what we've been doing everywhere else. So I can hit run, and I'm getting my current data. I can stop the auto scaling so you can see we're bouncing back and forth between the limits that I set. So between 0 and 2, we're just getting a sine wave going back and forth. And this is obviously a simulated device, but this code would run just fine on an actual device as well. You just wouldn't see the sine wave unless that's what you were actually measuring. So okay, that's method 1 of measuring current. Method 2, so now we're going to use the NI9205, which is not a current measuring card directly. So I have that here on mod 2. So again, we're going to leave it on analog input current. I'm going to specify that we have an external shunt, and I need to now specify the resistor value of that shunt. So 249, this is a very common resistor value, so 250 ohms is really typical to use with a 4 to 20 milliamp circuit. The reason being that 4 milliamps, and this is just Ohm's law, right? So V equals IR. If R equals 250, at 4 milliamps, we're going to be reading 1 volt. And at 20 milliamps, we're going to be reading 5 volts. So it gives you really clean numbers. Now, if we're doing a larger current range, like for example, the NI9227 goes to 5 ARMS, we might want to use a different value. And again, 1 ohm is a really good value just because it makes, math real easy. But again, DAQmx is doing this for us, so who cares what value we use, as long as it works for your circuit. So yeah, that's really all we need to change for method 2. We need to specify what our range is, right? Our min, our max. We need to specify the external shunt, and we need to make sure that we have defined that this is an external shunt. Now, we also need to specify the input terminal configuration. So because this is a voltage measuring device, there may be different ways that we can connect voltage to it. So let's go back to that NI9205. So if you look at this one, there's actually a few different ways we can take measurements. So differential is one way to do that, where we're basically saying positive is here, negative is here, and we're measuring the voltage difference across those. So this might be channel 0, this next one might be channel 1, channel 2, channel 3. So that's one way, and that would be differential measurement. Now you also can do like RSE measurements, which is basically going to be this channel 0 pin against our COM pin down here. So you can see it's labeled COM over here. There's our COM. So it would be that channel relative to this. And then this next channel, channel 1, relative to this, and on and on and on. So if you have a common ground that you can reference against all of these channels, that's a really easy way to do it. And you don't have to run a million ground wires to the opposite side. So that's why the input terminal configuration does matter a lot when you're using method 2 for measuring current, because it's going to define how you've connected things to your card. So yeah, let's say I'll just leave it as default. It doesn't really matter because it's a simulated device, but you'll want to select what is applicable to how you wire. All right, and then before we run this, I'm just going to change this 249 ohm resistor to 1 ohm, just because we are measuring a larger voltage range or a larger current range. If we were in the milliamp range, 249 is a fine value. I'm pretty sure that will throw an error if we do 249 with the way that's set up. So now let's go run this, and it runs just the same, right? We're able to see our current go back and forth in a sine wave. Just this way, this time now we're set up to have that shunt external to the device, and we don't require a specific card for measuring current, we can take advantage of a voltage capable device and that external shunt. So those are going to be the two different ways that you can measure current in LabVIEW using DAQmx. And again, there always is external sensors like current transformers and things like that you can use as well. But that's going to be something outside of just DAQmx itself. So I hope that's helpful, and thanks for watching.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.